Yes, students, coming towards the next topic of chapter number 2, solution. The next topic is about different types of solution, that is ideal solution and non-ideal solution. Okay, now while giving the introduction of this chapter, in that objectives, it was written that ideal solution. At that time, I was referring you that this is somewhat linked to ideal gases. Do you all remember what is ideal gases? In 11th standard we have studied about ideal gases, right, at specific temperature, at specific pressure, etc, etc, and we have got one formula, that is ideal gas equation. You remember that PV is equals to nRT. So that was ideal gas. Now coming towards our topic, that is ideal solution. So there are two types of solution, that is ideal solution and non-ideal solution. So initially let us study about ideal solution, and after that when we are going to study about non-ideal solution, you can also interlink between both of them. It will be very much easy to you all to remember if you remember in a comparative way. I hope you all remember that in school, if two things are contrary, we used to make in a form of differences, right? So in this also, that is ideal solution and non-ideal solution also, you can write in the comparative way while preparing your notes, so that you can remember that very easily. So ideal solution, what happens in ideal solution? In ideal solution, the Raoult's law under all the standard temperature and concentration means what? Ideal gas follows all the standard temperature and concentration, right? Means what? Ideal solution, first of all, it follows the Raoult's law, and when it follows the Raoult's law, then it also means that it is under standard temperature and its concentration. Okay, and when it is following the Raoult's law at constant temperature and concentration, it is not going to change the volume. That is delta V mixing is equals to 0. Now what is this delta V mixing is equals to 0? That is change in volume. Delta, you know that you are studying in your physics also and in maths also. What is delta? Delta means change, right? So when there is an ideal solution, means when the two components are mixing, after the mixing there is no change in the total volume of that. If for example component 1 has some specific volume like 5 ml, and component 2 is having a specific volume of 7 ml, and when it is forming the solution, then the volume of a mixture, that is the whole solution, will be 5 plus 7, that is 12, right? So there is no difference in the volume, means there is no loss of volume or there is no gain of volume in this, right? So that's why it is said that delta V mixing is equals to 0. Same way delta H will also not change. Enthalpy of enthalpy of component 1 and component 2 will be, when we are doing the summation of that, will be equal to the enthalpy, or we can say the temperature will be equal to the same. So why it happens like this in ideal solution? It is known as ideal solution, means there is definitely going to be an interaction. But how is it? We can also say that it is a solution of a two components A and B, in which A B interaction are of same magnitude as A to A and B to B interaction. Means obviously we know that in a solution there will be an interaction, even if we are taking only the components, that is component A and component B. So in component A we know that there is an attraction between A and A. In component B, we know that there is a attraction between B and B, right? And so when we are mixing this, that we are mixing both A and B, at that time also there will be an attraction between them, right? And this attraction will be A to A also, A to B also, and B to B also. So after mixing, the magnitude of A to A and B to B will be equal to AB in ideal solution. That is, interaction between AA and BB and AB will be of the same magnitude. Okay, that means the interaction of AA, AB and BB will be equal. Only solution with lower concentration of a solute behaves ideally. Means the solution in which there is low concentration of a solute behaves ideally. Okay. For example, benzene and toluene. Benzene and toluene. Another example is chlorobenzene and bromobenzene. These solutions behave as an ideal solution. Why? Because the component of benzene and the component of toluene, the attraction between components of benzene is equal to the attraction between components of toluene also, and is also equal to the attraction between components of benzene and toluene. Here, let me recall this again very fast, that ideal solution behaves Raoult's law with standard temperature and concentration. There is no change in the volume after mixing the two components. There is also no change in H. Also, how do we say that it is an ideal solution? We can say it is an ideal solution when the attraction between AA, AB and BB will be equal to each other. Also, in this, concentration of a solute is low and it behaves as an ideal solution. For example, benzene and toluene, chlorobenzene and bromobenzene.